More than being a student, a programmer, an engineer, a professor, an instructor, an accountant, we were, or rather, we still are the sons and daughters of our parents, of course. And that means we, at some point of our lives, have already washed the dishes. And after washing all those forks, spoons, cups, and plates, we dry them in a rock. At last, we put them in the right places. Have you ever noticed that we use the same set of plates and cups? It's simple. The plate which is at the top is the first one to be removed, and the plate which has been placed at the bottommost position remains in the stock for the longest period of time. Meaning, the last plate you've washed might also be the plate you'll get the next time you set the table. This is how the data structure stock and its operations are performed. It follows the LIFO, or last in, first out. It adds and removes elements based on LIFO, or push and pull, respectively, as what they've really called. One application of stock is very common and is often used, especially in writing documents, editing videos, or photos, is the redo and undo feature. When you click the undo button while typing an essay, you don't remove the first letter of your document. Instead, you remove the last one you type. So how do we use stock? There are actually two implementations of stock, wherein these two implementations are actually the two data structure we've discussed in the previous video. In array implementation, the stock is formed by using the array. All the operations regarding the stack are performed using arrays. It is easier to implement and does not require extra memory as it is not as dynamic as in linked list implementation. On the other hand, in linked list implementation, of course, all the operations are performed using linked list. It allocates the memory dynamically. In linked list implementation of stock, the nodes are maintained non-contiguously in the memory. Each node contains a pointer to its immediate successor node in the stack, according to Java point. Have you ever been in a line waiting for the jeep to come so you can just get home? How about lining up early in the ticketing booth just to be one out of 50 people to get a discounted VIP ticket to a concert? Or when the agent is taking too long in answering your call? It's all because you are not a VIP. You're not someone who can just get through a closed door without waiting in the line before the others. The early bird catches the worm. First come, first served. And this is also the case with the data structure queues. Queue is a linear data structure that follows the FIFO, or the first in, first out order, in which the first element is inserted from one end, called the rear, also called the tail, and the removal of existing element takes place from the other end, called as front, also called the head. Meaning, if you want to remove the second to the last element in the queue, all the elements inserted before the element must be removed first. To understand it further, I'll give you few applications of queue like task scheduling, call center, printing documents or pictures, etc. There are two implementations of queue, the array implementation and the linked list implementation. Just like in stack, operations regarding the queue are performed using arrays. You need to keep track of two indices, front and rear, because these variables point to the position from where insertion or enqueuing and deletions or dequeuing are performed in a queue. While in linked list implementation of queue from Java point, in a linked queue, each node of the queue consists of two parts, the data part and the link part. Each element of the queue points to its immediate next element in the memory. The operations performed in linked list implementation of queue are insertion and deletion, which are performed at rear and front end respectively. If front and rear both are null, it indicates that the queue is empty. This is a simple example of a Python program that implements stack. And this is a simple Python program that implements queue.